Can you do everything with human beings that you want to do? Let's go back to one of the most famous of all experiments, at Jenner, back in the 1830s or so. Before Dr. Jenner's work, 1/3 of all children less than 3 years old in England died of smallpox. 1/3 of all children under 3 died of smallpox. Last year in England, not one child died of smallpox. And why not? Because Jenner worked on the whole process of vaccination, created the process of vaccination. And once you have vaccination, you don't have that. But there was a moment in there which is very strange. And that's the moment when he had the idea of vaccination, but couldn't really be completely sure that it was correct. It was a new idea. He didn't know whether it was completely correct or not. Well, what do you do? What he did was, he took a young boy, gave the young boy cowpox, which is what he was going to use to produce the vaccine. The boy got a little disease of cowpox, a trivial sort of thing, a couple of days it vanishes. And then, several months later, injected him with smallpox. Now, if his vaccination process had worked, the child would be perfectly all right, nothing would happen. If it was wrong, the child would get smallpox and die a rather unpleasant death. Was that a valid experiment? Well, boy, I mean, those are questions that we have to discuss and have to think about. And you can't just say they're scientific questions. They're human questions where we have to figure out what is it to be a human being and what do we have to do to protect our humanness. What things ought we to do, what things ought we not to do. But oughtness is not a word that is used in science. Science is a description of what happens. What we are also interested in is what ought to happen. What are our responsibilities? So, what I would say, I know it sounds a little bit different from what you frequently hear religious people saying. Of course there's a conflict between science and religion. There always has been a conflict between science. There is right now today as we fight over research on embryonic stem cell research. There'll be another question in 100 years, I don't know what it will be, but there'll be one where you're dealing not only with trying to understand, but you're dealing with action, and therefore you're dealing not only with understanding, but what you ought to do. What is the oughtness in a given situation? And that's going to be with us. It's going to happen. It's never going to go away. The choice is, we can say, okay, we're going to have these border fights. Borders are going to clash. We can do one or two things. We can have a fight, or we can have a conference. It's much more fun to have a conference. Okay. Now.
Okay. Are you open for questions?
Yeah, sure.
Okay. All right. Does anybody have any questions here? I know you do. I just have to get the taser to get you out here. So.
Yes, Billy.
Will you share what your belief is? Like, do you believe in evolution and it being compatible with religion, or will you share your opinion?
Yes, I'm a physicist. And as a physicist, I must admit, I have approached the question from the point of view of cosmology more than biology. And so I go back to the 1925s when Edmund Hubble, after whom the telescope was named, the Hubble telescope, first announced to the American Astronomical Society in a famous meeting that he was able to see that all the galaxies in the universe, with the exception of a couple close to us, are moving away from us. That is to say, that the universe is expanding. It was a brilliant lecture, so brilliant as a matter of fact that after he finished, and it was just an ordinary paper at a science meeting, everybody clapped and stood up and clapped. So when you take that idea and go backwards, if the universe is expanding at this moment, then in an earlier moment, things were closer together. And if you go back further and further and further and further, you must get to a point where everything was on top of everything else. And that's the concept of the Big Bang. It's interesting that Einstein originally didn't like this idea at all. Einstein, although he was a very modern thinker, was trained in Newtonian physics. And in Newtonian physics, the universe is infinite size and infinite in time and unchanging. It doesn't change. And when in his own equations for general relativity, it turned out that they don't have a really good solution for that. That the solution either shows that the universe is expanding or contracting. A stable solution is impossible. He had to rig something he put into the equation to make it balance out. So he held to the idea that the universe was the same throughout all of time. It didn't change. So when somebody like Abbe Georges Lemaitre, a Belgian diocesan priest, educated at MIT, but in many other places, also in Europe, when he came out with what he called the theory of the primeval atom. The theory of the primeval atom was that the entire universe started in some very condensed state and then expanded. Okay. So he came out with that theory. Einstein originally reacted to it by saying this is the stupidest thing he had ever heard. And he was at the paper where, the meeting where Father Lemaitre gave his paper, and just condemned it outright as total nonsense. And then, of course, Edwin Hubble came out with his scientific proof that, well, that's just what the universe is doing. It's just exactly. So Einstein changed his opinion. The next time he was at a meeting when Father Lemaitre gave some similar paper, he said that's the best he's ever heard. So he changed. But that is part of science, though. Even the greatest of scientists change opinions. If the data is new and different, you have to understand it in a new way. So you have to have almost a sort of a humility there. But that, to me, does show that the universe changes in time. So the universe, there is something like a Big Bang, and that then does bring about some kind of development. If there is a physical development, then it's not surprising that there would be a biological development also. Now, you see, behind all of that, though, you go with a little bit of Einstein's thought for this, because Einstein happens to be one of my heroes, even though there are some things I don't agree with. What Einstein is going to say is, do you see what's happening here is if we ask a true scientific question, a valid scientific question, that scientific question is going to have a scientific answer. So if you say to yourself, the other day it was snowing, and you say, well, why was it snowing? Well, you can say, because God was mad at Baltimore and wanted to punish Baltimore by sending a blizzard. That doesn't sound like a scientific answer. Scientific answer must be something having to do with relative humidities, the motion of air masses, the motion of energies that are flowing from the sun to the earth. So what Einstein would say is, what you notice is that to every scientific question, every valid scientific question, there's a scientific answer. Now that's an act of faith. An act of faith. For instance, let's take Alzheimer's. The worst problem we face right now is Alzheimer's, because our population is getting older. It's a disease which affects older people. We're getting more older people. We're getting more Alzheimer's. It's a very, very bad disease. We don't know how to cure it. We don't know why it happens. We don't know how to treat it. But we have perfect faith that if we keep studying human personality, human reality, we'll find a cure. Can you see that that's an act of faith? I can't prove that to you. I can't prove to you that if we study long enough, we'll find a cure for Alzheimer's. But I absolutely believe it. And so does every scientist. So all of science is based upon an act of faith. An act of faith that A valid scientific question has a valid scientific answer. And now Einstein, after he says all of that, he says, now look at that, that's what's happening, that's what we see, that's what our belief is, that's what the structure of the real world is. Now let's ask ourselves a question. Why is science possible? Why does this work? Why is science possible? And you can answer that question in a variety of ways. One possible answer is, look, it just does work. I mean, don't bother me. It's two rocks banging together in empty space, and that's the explanation. Go away, leave me alone. Or you can say,